Good morning, good afternoon, good evening, whatever time you have, and welcome to Unit 3 of Module 1, which is titled Set of Numbers. We've discussed what a set is, and we've talked about the properties of sets, that arithmetic in sets. Now we want to know, set generally, we talk about sets generally. A set of human beings, set of trees, set of students, set of electronics. But now we want to be specific. Set of numbers, which are very, very useful in mathematics, most especially in analysis. You also in business world, we transact with numbers, and all that, numbers of employee, numbers of equipment, the numbers of customers, numbers of this, numbers of that. So we'll be talking about set of numbers. Let's go. So most important of all is the set of real numbers. Now what are real numbers? So here our universal set will be set of real numbers. So, in your lower classes, you are familiar with what you call rational number, irrational number, set of integers, natural numbers, and the likes. So, but the real numbers is comprised of all the numbers you have known before. They are subset of real numbers, be it rational, irrational, continuous. Any form of number you are aware with, they are all subset of real numbers. Now, what you expect to know or to learn at the end of this unit, you expect to state classes of real numbers and their properties, and also to be able to perform basic set operations on intervals of numbers. Of course, we're talking of intervals of numbers and more. Now, concept of real numbers. Real numbers basically can be represented on the real line. What do you mean by real line? You know what you have in your primary school. You draw a number line. You have 0, 1, 2, 3 to your right, and negative number to your left. So real number can be represented on this, can be equivalent to this. There is no number that you cannot represent on this number line. Look at this figure 3.1. Look at, you have this 0 at the middle, and to the right you have positive. You can represent half with type between 0 and 1. You can represent 1.5 between 1 and 2. You can represent even square root of 2. You can represent e. You can represent pi, which is 3.142. Any number you can represent there. Even to the negative side, you can represent minus pi and all that. You can represent minus half, minus 2.3. So real number, real numbers consist of all numbers except complex number. We will not go there now. Now, what are the classification of real numbers? As I've said before, real numbers can be classified to all the numbers you are familiar with before. We have set of rational numbers, which we call Q. So rational number is any number that can express as A divided by B, where A and B are set of integers, and B not equal to 0. So a rational number, not a ratio of integers, and they are not terminating decimals. Example is root 2, non-repeated and non-terminating decimal, and pi. They are irrational numbers. You cannot express them as a ratio. And if you put it in decimal fraction, it is non-terminating or non-recurring decimals. Also, we also have set of integers. These are whole numbers, including negative and 0, and positive numbers. Natural numbers, what you know, that we know, that we are familiar with, you can represent this. This is 1 paper. This is 2 paper. 2 paper. These are natural numbers. These are natural numbers. So we also have set of whole numbers. This is a natural number which includes 0, and we also have prime numbers. These are numbers which has exactly 2 factors, 1 and itself. So all these are subsets of real numbers, and there are classes of real numbers. Now, this picture shows the relationship between classes of numbers. So, as I said, complex number is more general than real numbers, but we are not going to that place now. So, real number, which we are our concern now, is more universal than rational number. It contains rational number, irrational number, integers, zero, negative integers, natural numbers, prime numbers, and the likes. So these are the real numbers. Now, properties of real numbers. We have commutative property. That is, if you pick any two numbers, it doesn't matter the arrangement. If you're adding, if I say 2 plus 3 and I change it to 3 plus 2, it will still give me the same number, the same answer. 2 plus 3, 5. 3 plus 2, 5. If it's multiplication, multiplication is also commutative. 2 times 3, 6. 3 times 2, 6. It doesn't matter which one comes first. That is commutativity property of real numbers. Associativity is also A plus B plus C is the same thing as A plus B plus C. A plus B plus C is also the same thing as A plus B. It doesn't matter which one come outside. The same thing applicable to multiplication. Associativity is applicable. So we also have distributive. We say here that multiplication is distributive over addition. That is, A multiplied by B plus C is same thing as is equal to A plus A times B plus A times C. And also have identity. A plus 0 give us A, and A multiplied by 1 it give us A. So that means 0 is multiplicative inverse, additive inverse. 0 is additive inverse, while 1 is a multiplicative inverse of A. So inverse of A will be A raised to power minus 1. So let's go to another set of numbers. Let's talk of inequalities. What do we mean by inequalities? We are just expressing that one number does not equal to the other. Maybe we want to compare your age to my age. Our age, maybe I'm 40 and you are 30. You want to compare them. You can now say, okay, your age is less than my age. So that if my age is A, your age is B. That means your own age is B, my own age is my own age is B, your own age is A. That is maybe you are 30 and I'm 40. That means 30 is less than 40. Your age is less than my age. So inequalities, if you have A, you have two real numbers, A and B, and you say A is less than B, it means that if B minus A is positive, that means A is less than B. So if you subtract your age from my own age, that means you have 10, which is positive. So if it's A greater than B now, what I'm going to have is it will be negative. So we are just expressing that two numbers are not equal. That is what we call inequality. They are not equal. So we are trying to order set of real numbers. That is, one is greater than this, or the two numbers are equal, or they are not equal. So that's what we are trying to do. So let's go to absolute value. What do we mean by absolute value? The absolute value means in our number line, we have origin 0. So from that origin 0, no matter whether you go to the left or you go to the right, if you take your ruler and measure the distance, you will not get negative distance. It is just an abstract that will say one is negative, to one side is negative, to one side is positive. But if you measure the distance in natural sense, you cannot get negative value. So this is what absolute value is telling us. The absolute value says the value of a certain number, whether measuring from that 0, will always be positive. So we said absolute value of S equal to X if S is greater or equal to 0. But absolute value of S equal to minus S if S is negative. That is x is less than 0. If x is negative, absolute value of x is minus x. If x is positive, the value of positive for greater than or equal to 0, absolute value of x is equal to x. That is, we are talking of distance from 0. Example, if you have absolute value of minus 2, it is equal to 2. If you measure it, the absolute value from 0, it will be 2. If you go to the right also, it will be 2. So, also absolute value of 7 is 7. So, we are saying absolute value of minus 2 is equal to 2. Look at the definition here, this diagram, on the right hand side. You see, absolute value of minus x is equal to, minus x is equal to x. So inequality with absolute value of a certain number describe the distance. We are just describing the distance from origin 0. So when you take your ruler, measuring from 0 whether to the left, which we call negative, you cannot get negative something, no, it will be maybe 2 or 7 or anything. So intervals, this is very interesting aspect also. Intervals. When we talk of intervals means the number under consideration or the distance we are considering. Take for example, we have a finite interval. What do you mean by finite interval? We look at what we have here. We have the interval between 2 and 5. Interval between 2 and 5. Look at this. So, look at this, the first one, A1. The interval between 2 and 5, both of them are not included. And it is called open interval. The first one is called open interval. We are considering distance between 2 and 5. But look at the parentheses there. They are not square brackets. They are just ordinary brackets. That means 2 and 5 are not included. Do you get that? The interval we are considering the distance between 2 and 5. We are considering between 2 and 5, but because it is an open interval, we call it this open interval because both brackets are not square brackets. So we are considering distance between 2 and 5, and 2 and 5 are not included. It's like you are saying your x is between 2 is less than x less than 5. That means 2 is not included and 5 is not included. The second one, A2, we are having square brackets 2, 5. Now we are considering the interval between 2 and 5, both inclusive. 2 is part of what we are considering, 5 is also part of. That's what we call close interval. A1 is called open interval, A2 is called close interval. A3, we call it open close interval. Look at the first one is ordinary bracket, while the other one is close bracket. That means open close interval. That is open close interval. That means 2 is not included, but 5 is included. Now for A4, we call it close open interval. 2 is included, 5 is not included. These are called intervals. So we also have infinite interval. You know, you are starting from 1 is not included and infinity is not included. Look at this one. All this one, we are talking of infinity here. So we don't know the end. So we call it finite interval. Bounded and unbounded set. A subset of finite interval. A set is said to be bounded if there exists a particular real number n, such that absolute value of x is less than or equal to n. That is, as a particular number, that the number that set cannot be more than. Take for example, the age of human being on Earth is bounded. We can say it's bounded by 2,000. There is nobody that can live up to 2,000 years. So we can say the age of human being is bounded by 200. If I can find a particular number in R, say 2,000, that age no human being can be above that age. So I can say the age of human being is bounded by 2,000. I can even say the age of human being at this present age is bounded by 200. No human being can live up to 200 years. So it's bounded. That is what we call boundedness. So unbounded, if it is not bounded, that's just the example. And we have example here. Bounded and unbounded. So I urge you to practice some exercises in your lecture notes. Thank you for your time and have a great day.